All right, our second lesson here on Unit 4. So we're in our exponent properties again. Yesterday we talked about all of our different multiplying exponent properties, multiplying like bases, power to a power, power of a product, things like that. So today we're going to talk about our quotient properties or our division properties. So this will be the last of them that we're going to do before our quiz. We're also going to put in there some zero exponents as well. So we're going to get into those. We'll have a pretty good list of properties that we can do quite a bit with after today's lesson. So our warm up for today is just to see how well you remember the things we talked about yesterday. So go ahead and pause your video and see if you can do those looking at what we did yesterday. All right, so in number 1, I see y to the 8th times y to the 11th. Those are like bases. When I'm multiplying like bases, I add the exponents. So I get y to the 19th for number 1 there. Okay, now in number 2, I've got a little bit more going on this one. 3y to the 3rd in parentheses, all raised to the 4th power, times y to the 5th. So the first thing I see here is that I have an exponent outside of parentheses and all multiplying on the inside. So I am going to distribute that exponent to both of the bases inside. So the first base is a 3, so that becomes 3 to the 4th power. Remember, you're going to actually write that numerical base with the exponent rather than just multiplying, because it is not 3 times 4. It's 3 to the 4th power. Okay? Then I'm going to take that exponent and distribute it to my second base, which is y. Now that one already had an exponent, so when I have a power to a power like that, I am going to multiply. So this becomes y to the 12th. And then I'm just bringing down my times y to the 5th because that didn't change at all. All right, so now I see that I have a numerical base. Remember, whenever I have a numerical base, I want to actually multiply that out. 3 to the 4th power. 3 times 3 is 9, times 3 is 27, times 3 is 81. And then I see that I have two like bases here, y to the 12th times y to the 5th. So I'm going to add those exponents and get y to the 17th. So 81 y to the 17th for my final answer. So those were review from yesterday, right? And in fact, we hit all 3 of our properties from yesterday in those 2 problems. In fact, all of them in problem number 2. So we have power to a power where we multiply our exponents. We have power of a product where we have to distribute to every base inside as long as it's all multiplying going on the inside. And then if I'm multiplying any like bases after that, no parentheses anymore, then I just add my exponents. So today we're going to throw in some dividing ideas, right? Dividing is when we deal with our fractions. So the first thing we're going to talk about is what happens when I'm dividing like bases. So yesterday we were multiplying like bases, all on the same level. Today we're going to divide. So this is where things get a little bit tricky, but if I look at number 1 here, I have x to the 5th over x to the 3rd. That really means that I have 5 x's on the top, right? And I have 3 x's on the bottom. Okay, 5 x's on the top and 3 x's on the bottom. So then when I have the same thing on the top and the bottom of a fraction, they cancel out, right? So this pair will cancel, this pair will cancel, and this pair will cancel. So what I'm left with is 2 x's that are both on the top. So that would be like x squared over 1. Or we could just write that as x squared. Now, if you look at number 2, on number 2, I have x squared on the top, which is really 2 x's on the top. And I have x to the 6th on the bottom, so that's 6 x's on the bottom. All right, so again, same thing on the top and the bottom will cancel out. So I'll have 2 of these pairs that will, whoa, sorry about that. 2 of these pairs that will cancel out. So I'm left with 4 x's left on the bottom. So that means that would be 1 over x to the 4th. I would have x to the 4th, and it's going to be on the bottom of the fraction. Okay? Now, if you go back and look at how that happened, on the first one, I have x to the 5th over x to the 3rd, and I get x to the 2nd, and it's on the top because the bigger exponent was on the top. On the second one, I have x to the 2nd over x to the 6th, and I get x to the 4th on the bottom because the bigger exponent was on the bottom. So what I'm doing is I'm subtracting my exponents, but I'm always writing my answer wherever the bigger exponent was. That's the tricky part about dividing like bases when I'm subtracting the exponents. So I subtract exponents and put the answer where the bigger exponent was, right? Now, when I say subtract the exponents, that really means I'm always doing the bigger minus the smaller. Whoops, sorry about that, guys. Subtract exponents. Bigger minus smaller, right? I did 5 minus 3 and I got 2. I did 6 minus 2 and I got 4. And then you're just going to put your answer where the larger exponent was. Okay, so you shouldn't get a negative number here. You should always get a positive answer, and then that answer will go wherever the bigger exponent was. All right. Now, the next one, power of a quotient. So this is when I have an exponent outside of parentheses and I have dividing on the inside, right? So it's very similar to power of a product, but power of a quotient is when it's dividing on the inside. So in number 3 here, I have x over y to the second power. Well, something to the second power is really times itself, right? So this is really x over y times x over y. And if I combine those into one fraction, there'd be 2 x's on the top, right? And there'd be 2 y's on the bottom. So that would become x squared over y squared. Well, I could get the same thing if I just distribute that exponent to each of the bases inside the parentheses. It just happens that one is on the top and one is on the bottom of the fraction. So it's working exactly the same as it did yesterday. So if I look at number 4, 2x over 3y all to the third power. Again, just like yesterday. So I'm going to distribute to every single base inside these parentheses. It just happens that there's 4 of them, but 2 are on the top and 2 are on the bottom. So it's become 2 to the third, x to the third on the top, 3 to the third, y to the third on the bottom. So you distribute that exponent to every single base, top, bottom, doesn't matter, as long as you have either multiplying or dividing inside the parentheses. Now, just be careful. If I was going to finish this one out, I'd want to make sure my numerical bases were multiplied out. 2 to the third is 8, so I'd have 8x to the third. 3 to the third is 27, y to the third on the bottom. Okay, so on this one, what I did, when I have power of a quotient, when I have dividing inside those parentheses, I just like power of a product. So I distribute the exponent to every base inside the parentheses, whether it's on the top or the bottom, it doesn't matter. So same thing as product here on this one. Okay, now our last one is dealing with a zero exponent. Now, zero exponent is a tricky thing to wrap your brain around, but I think it makes the most sense after thinking about how we just did our dividing like bases up at the top, right? So when we did our dividing like bases, we talked about how we would subtract our exponents. So we subtract our exponents, right? And so I say x to the 6th over x to the 6th. If I subtract my exponents here, you could say that I would get x to the 0 power, right? But you can also think about, remember what happened when I had the same thing on the top and the bottom of the fraction. When I have the same thing on the top and the bottom of the fraction, they cancel each other out, right? 6x's on the top and 6x's on the bottom cancel out. And when things cancel out, that means they equal 1. So anything to the 0 power actually equals 1. And you can think of it because it's like having the same thing on the top and the bottom. When you would subtract your exponents, it would be, they would give you x to the 0 power, sorry. Okay, so anything to the 0 power equals 1. Anything to the 0 power equals 1. So before we move on past our zero exponents and all of our other properties here, I just want to do a little practice with the zero exponents that's not written here. So the tricky part with zero exponents is, like figuring out what actually has the exponent of zero. So for example here, I'll just make this number 7. I could have something that looks like this. 5x all in parentheses to the 0 power, right? Now if I look at this, I know my properties from yesterday, and that would say that every base inside these parentheses gets that 0 power, right? So the whole thing has a 0 exponent, so this would equal 1. But the tricky part is sometimes I have things that look like this. 5x to the 0 power with no parentheses, right? And so when I have 5x to the 0 power with no parentheses, what that really means is the x has the exponent of 0, but the 5 doesn't. That 0 doesn't get distributed. The 5 has that invisible exponent of 1. So this is really like 5 times 1, because the only thing that has the 0 exponent is the x. And 5 times 1 would equal 5. Okay, so just so that you can see the difference, be careful. If you have more than one thing in your problem and with the 0 exponent, watch for those parentheses. The only time the 0 exponent goes with everything is if there's parentheses. And if there is no parentheses, then only the base that it's attached to gets that 0 exponent. All the other bases would have their invisible exponents of 1 unless another exponent is written. So that's the tricky part about the 0 exponent idea. Okay, so those are our 3 new exponent properties. When I'm dividing like bases, I subtract my exponents, bigger minus smaller, and then I put my answer wherever the larger exponent was. When I have power of a quotient, just like power of a product, when I have that exponent outside of parentheses, if I have multiplying or dividing on the inside, I distribute that exponent to every single base inside those parentheses. Just watch, some of them might be on the bottom of the fraction now. And then the last one is whenever I have a 0 exponent, anything to the 0 power will equal 1. So now let's practice, okay? First, we're just going to practice with our dividing like bases. That's the most often used here. So number 1, n to the 24th over n to the 18th. Okay, so again, I have like bases here, so I'm going to subtract my exponents. So I do 24 minus 18. Now you don't have to write this out, right? 24 minus 18 gives me 6. So I'll have n to the 6th power, and where was the larger exponent? Larger exponent was up on top. So this becomes n to the 6th power over 1. Or you don't really have to write the over 1, and you don't really need this step at all. You can just write n to the 6th power like that. If it's on the top, you can just write it how it is. Okay, so again, this part right here was mental math. I just kind of wanted you to see what I was going through as I was doing that. So you don't have to write that step out. Okay, so number 2 now, it says x to the 10th over x to the 12th. So in my head, I'm thinking, all right, subtract the exponents. 12 minus 10, right? 12 minus 10 gives me 2. So I have x to the 2nd. Now, where was the bigger exponent? This time the bigger exponent was on the bottom. So my answer should be 1 over x to the 2nd. That one you have to have. If I want my answer to be on the bottom and there's nothing left on the top, I have to put a 1 at the top of on the top of that fraction. All right, now number 3, what's the missing exponent here? X to the 8th over x to the what power equals x to the 6th. All right, now when it says x to the 6th, that really means x to the 6th over 1, right? Which is telling me that their leftovers are going to be left over on the top. So the top number has to be the larger exponent. So I have to do 8 minus what would give me 6. Right? Now, if that was 1 over x to the 6th, I'd have to know that the bigger exponent was on the bottom, and I'd have to do something minus 8 equals 6. But here, I know that my answer ended up on the top, so that means that the bigger exponent was on the top. So 8 minus what equals 6. Hopefully, that's a pretty easy mental math to do, and you'd say 8 minus 2 equals 6. So that missing exponent is a 2. All right, now let's practice with combining some things here and getting a little bit more complicated. All right, number 4, negative 24x to the 10th over 6x to the 6th. Now I've got more going on because I've got these coefficients. Now this is the trickiest part. I see I have negative 24 over 6. Now remember, these are not exponents. These are regular numbers. If I covered up the rest of that fraction, it would just say negative 24 divided by 6, right? So I'm just kind of thinking this like this. This is a normal, these are normal numbers that I am going to divide. That fraction bar means divide. I subtract my exponents, but not coefficients. Coefficients I need to divide. So negative 24 divided by 6 gives me negative 4, right? And that would be on the top of my fraction. So I would get negative 4 when I do negative 24 divided by 6. Then I see that I have these like bases, right? I have x to the 10th over x to the 6th. This is like what we've just been practicing. There's 10 x's on the top, there's 6 on the bottom. 10 minus 6 gives me 4, so I have x to the 4th left. The larger exponent was on the top, so I would have x to the 4th on the top with my negative 4, right? So I could write it as negative 4 x to the 4th over 1, or we can just write it as negative 4 x to the 4th. You don't have to write that over one step if you don't want to, but sometimes it's hard for us to wrap our brain around if it's on the top or not. Okay, so just remember those coefficients, those big numbers in the front, that's a dividing problem, right? That fraction bar means divide. So big whole numbers, coefficients, I have to divide. Only exponents I subtract. Easy thing to mess up. All right, number 5 here, I see that I have a fraction inside of parentheses with an exponent outside of it. So I have dividing inside the parentheses, which means I'm going to distribute this exponent to every base inside those parentheses. So x to the 4th to the 5th power. And remember, a power to a power, I'm going to multiply those. So this is going to be x to the 20th on the top. And then down on the bottom, my base on the bottom is y to the 3rd. Again, power to a power, I'm going to multiply. So I get y to the 15th on the bottom. Now those two are not like bases, so I can't do any more than that. Okay, now number 6, very similar, right? I've got some multiplying and dividing inside my parentheses with an exponent outside. So I'm going to distribute that exponent to every single base. So my first base is negative 7. So I have negative 7 to the 2nd power. And be careful that you're using parentheses when you write that out. And then I have y to the 2nd power also on the top. On the bottom, I have the base of x, so it needs to be x to the 2nd power on the bottom. Notice how all 3 bases got that exponent of 2. Last step here, then, I see I have a numerical base. Now be careful, negative 7 to the 2nd power. Negative 7 times negative 7 gives me positive 49. So I should have positive 49 y to the 2nd over x to the 2nd as my final answer. All right, last couple just to really kick it up, make sure that you're really feeling confident in all of these. Okay, so number 7, the first thing I notice, I've got a couple coefficients, right? 8 over negative 32. So again, I'm going to divide that, or I think about that as the fraction, 8 over negative 32, and I want to reduce it. Okay, then I see that I have like bases with my x's, x to the 2nd over x to the 6th. Oops, sorry about that. Pen went crazy. Okay. And then I just have a y to the 6th that doesn't have any other like bases, so it's going to stay how it is. All right, so first let's deal with our coefficients. 8 over negative 32. So you can think of that as 8 divided by negative 32. You can think of it as the fraction 8 over negative 32 and you want to reduce. It also works with our little trick where we do bigger divided by smaller and put the answer where the bigger number was. Just like we do with our exponents. Works with dividing when we're dealing with fractions as well, as long as it divides out evenly. Negative 32 divided by 8. So I get negative 4, or really, in this case, it'd be 1 over negative 4 because the 32 is the bigger number down at the bottom. So I would get, in my fraction, negative 4 down at the bottom. You could put the 1 on the top, but you really don't have to, because unless there's nothing else left on the top. Let's see, now with my x's, x to the second over x to the sixth. 6 minus 2 is 4. I have x to the fourth left, and the bigger exponent was on the bottom. So I'm going to make sure that I put x to the fourth on the bottom. And then, like we said, there is no buddies for y to the sixth, though he stays up on top. Since I did have something left on top, I don't have to write the 1. It could say 1y to the sixth over negative 4x to the fourth if you want to, but you can leave it just like this as well. All right, number 8. There's a lot more going on number 8. This is kind of an intro to what we're going to do tomorrow. We're going to combine a whole bunch of properties all in the same problem. Now, here's my recommendation. Yes, you can see that exponent outside of the parentheses, and you're probably itching to distribute it, but I say wait. Simplify your fractions before you distribute. If you start distributing to all of those bases, it's so likely you'll miss something, you'll goof something up, you'll make a little mistake. Instead, simplify inside before distributing. Whenever possible, do that. Now, sometimes you won't be able to simplify anything. In fact, that's happened quite a bit as we were moving up here, right? But anytime you possibly can, simplify before distributing. So here I see I have my coefficients, 6 divided by 3, right? So I'm going to try and simplify as much as I can in these parentheses before I actually write my, distribute that exponent of 3 outside. 6 divided by 3 gives me 2. Bigger number was on the top, so I'm going to put my answer on the top. Remember, again, those are coefficients, so I divide, not subtract. Here I see my like bases of x on the top and the bottom. So I have x to the first, right, that invisible 1 on the top, and x to the third on the bottom. So I have x to the second left, bigger exponent was on the bottom, so I'm going to have my x to the second on the bottom. Okay, now I see I have like bases of y on this one too. I have y to the first on the top and y to the second on the bottom. 2 minus 1 is 1 left. Bigger exponent again was on the bottom, so I'll have just a y left on the bottom. I'm just going to scooch this 2 to the middle. Okay, so after simplifying, I have 2 over x squared y. That's way easier to distribute. I won't goof that up for sure. So now I'm going to start distributing my exponent to all the bases inside. So this becomes 2 to the third on the top. Distribute to my base of x on the bottom. There was already an exponent there, so I multiply and I get x to the sixth. And then distribute to my base of y on the bottom as well, and it becomes y to the third. Final step here is I see I have a numerical base. 2 to the third becomes 8 over x to the sixth, y to the third. All right. So just to kind of wrap it up, remember these were the properties we talked about today. When you're dividing like bases, sorry, that is a typo. Hopefully I'll have that fixed up before you guys see it. It says subtract exponents, base stays the same, and put your answer where the bigger exponent was. Okay, and then we have power of a quotient. That's an exponent outside of parentheses with dividing on the inside. And I did just like power of a product, distribute the exponent to every base inside the parentheses. And then 0 exponent, any base to the 0 power equals 1, right? We didn't practice that too much up here, but we will practice that more tomorrow as well.